So in this problem, all the resistance is equal to 2 ohm and we are asked to calculate the effective value of resistance. So in this circuit, we again talk about symmetry. So whenever we say that a circuit is symmetrical, we mean to say that all the nodes which are perpendicular to the symmetrical nodes are equipotential. So I can say that C and E will be equipotential. I can remove this 2 ohm resistance and I can also remove this 2 ohm resistance. Or we can also say that there is a Wheatstone bridge which is balanced Wheatstone bridge, and hence we can remove these 2 ohms on the either side. On removal of these two resistance, the circuit is reduced to a much simpler circuit where there is a 2 ohm and then another there is a 2 ohm followed by another layer of 2 ohm and 2 ohm. This is the connection in between, that is 2 ohm, and a similar pattern is drawn on the other side, something like this. So now if we calculate the effective value of resistance in parallel, so one is 4 ohm, another is 4 ohm, another is 2 ohm. Now there is a repetition of 4 ohm twice, so I'm writing over here again 1 by 4 and again 1 by 4. So let us write it this way and then I can solve it in the next line. So R parallel is 4 by 4 plus 1 by 2. So we get a value equal to 3 by 2. So Rp is equal to 2 by 3 ohm. So for this problem, the answer is 2 by 3 ohm.